So is it better to wait just a couple of minutes before I start anything?
Yeah, let's just wait 1 minute to see
Yeah.
if more people will join, and then you can start.
Can I do like voting and all that stuff? No.
I believe that's in the webinar option, isn't it?
Yeah. Where's chat? I can't see chat message either. Oh yeah, chat. Yeah, here you go. Okay.
Okay, I think we can start. Welcome everyone to our first Browsers 3000 learning session. Our first one was in Makoto. Makoto is one of the core developers of Ethereum Name Service, which provides NFT compliant naming service to various blockchain addresses and decentralized file systems. He's also a co-founder of Ethereum-based event service called Kickback and hosts events such as London Ethereum Code-Up. Welcome, Makoto.
Okay, thank you for, so I didn't know I'm the first one, so I'm very privileged, like, thank you very much. And I think, probably if you are in Asia, maybe late, but if you have in States or North America, might be still quite early in the morning. I'm actually based in Europe, London, and hello, my name is Makoto, and yes, I'm a dev Ethereum Name Service, and then last week I did some brief overview of what ENS is. So I do hope people knows what ENS is, but at the same time, I am aware that this is a kind of like a not necessarily a blockchain hackathon, but it's more wide, like browser related hackathon. So I don't assume that you know like basically Ethereum as a blockchain. So I'll try to kind of go down to very basic and assume that you haven't even touched it. So some of the basic might even include kind of basic of how to use blockchain stuff. And just to recap what ENS is basically ENS is a naming service. So that like if you do have some sort of crypto asset like ETH, BTC, Doji, or something, you usually need an address where you send your asset. And for Ethereum, it looks like this hexadecimal version, which is not really user friendly. So we provide a naming service so that, like in my case, I have something called matoken.is. So if you go to, for example, have I shared? I think I haven't shared yet. Yeah. I was speaking on the assumption that I have a slide, but yeah, I'm already page 3, but let me start from page 1. And so this is usually the same address, and we provide a naming service. So like this is actually my name called matoken.is. So like let me just quickly exit. So basic use case is like if you have a crypt address and if you say send something, and if you do matoken.is, it shows up that like address name related to address. Unfortunately, this one says like some error, says like M looks like the combination of R and N. So it says like, oh, it might be a scammy name, but like it's actually this is my name. And also you can see at the other location, like for example, let's see, OpenSea. So like NFT, non-fungible token, is now getting very popular among not just people who's into crypto, but like if you go to OpenSea, you see lots of NFTs, right? And the first thing is if I go to how do I connect? Yeah, let me try. Token.is. You can see that it's actually ENS is an NFT, so you can actually sell or transfer names as well. But at the same time, like if you go to and also ESA scan is often used kind of block explorer where you can see the activity of what I've been doing. And in this case, yeah, you can see that my address is this. And but you can also look up using matoku.is. And also, if you go to OpenSea, I'm quite sure that, yeah, ENS is integrated at over 200 different like wallet exchanges, dApps. So like if you can actually search my account, OpenSea account name on the NFT marketplace. So that this is basically all my NFTs I hold, and matoku.is. Also, interestingly, matoku. In this case, it's a bit, I named these parts as a username. So it comes up as matoku.is, but this is the Ethereum address, as you can see in OpenSea, which it's also tied into matoku.is. So if I look into other, I think, people please there. .is. Yeah, so this person is very famous in the kind of Ethereum space as an NFT artist, and in her case, her username is people pleaser. Ethereum address is x19EB, but you can also, it automatically shows your ENS name, and that's where like it's being used everywhere. And let's go back to the slide. Yeah, so today I will talk about, so in the last week's talk, I talked about like, this is, you can do so many different things, and also you can, for like could use as a login or could use for other purposes. But like for today, I'll just get back to the basic. And the first I start about just how to register the name if you don't have any. And if you're a developer, if you're creating an app, I'll quickly show you how to set up like a dApp, which talks to Ethereum smart contract, and also add a quick ENS support. And if I have a time, I will go through ENS as core protocol, which is also smart contract, and I'll see what it is like. Okay, so first, registering ENS is, yeah, so assume if you have something like Opera browser, Opera comes with wallet automatically. So if you go to Opera and say up, you can do it. Otherwise, you basically have to go to browser, Chrome plugin. Oh, actually, let's go to MetaMask. Yeah, otherwise, most common way is to use something called MetaMask plugin, which is supported in like Chrome, Firefox, Brave, and the Edge browser. So like you can kind of open it, and you can see like my name, pointing to address, and how much ETH I have. And most of the time, like to have a real ETH address, you usually go to mainnet. But like for dev purpose, you usually like connect to one of these test networks. So in my case, I connected to Goerli test. So you first install, and yeah, you point to like Goerli network. If you wanna do it for real, you have to go to like exchange like Coinbase to get ETH. But in most of the test case, that like usually there's something called faucet. So like if you go to like Goerli test faucet, yeah, like you kind of quite often what you do, like you type you first create a wallet, generate address, and then you copy and paste, tweet it, and then if you copy and paste that into this one, they usually give you like free ETH on the test net. So by doing that, I have like 1.6 like fake basically ETH. Assuming you do have it, you go to our app ENS domains site, which is the site ENS team built, but it's the entire protocol is smart contract, so you could do interact directly with, you can build your own front end, and then directly register, but probably easiest is going here, and if you go to browser 3000, it's available. So yeah, it just says like it's around like $5 per year. So like you just force the request to register, and yeah, something pops up, and I think let me just put gas price. And if you are pretty new to Ethereum, yeah, there's a notion called gas that you basically pay part of the usage of the Ethereum to someone called miners, who basically kind of sustain a decentralized distributed ledger, and you pay the fee to them. And so this one is also interesting that like when you register, you can't just register in one transaction, because the nature of the Ethereum blockchain is that everything is public. So if you just say, hey, I want to have like browser 3000.eth, when you're sending the transaction, sometimes it takes like 5-10 seconds, but sometimes when gas price is very high, due to the congestion, like when it gets like very popular, sometimes it might take 5 minutes or 10 minutes, or it never settle. And while people, when it get congested, if you are just sending the transaction normally, people can actually see what you're doing. And actually, I think I can show it to you. Visa scan, for example, I think register INSS. Yeah, these things, like it's pending, right? Like, so you can see that these people, and you can actually see like what it's calling, and you can even like decode that kind of stuff, and it exposes a name. It shows you're trying to register, so someone can fetch it. That's called like front running. So to prevent that, we use so-called, it's very kind of basic pattern in the sending transaction in Ethereum is called commit and reveal method. Like when you commit, you kind of hash your name with certain salt and certain secrets, and you commit it. And this one, like after a transaction gets mined, you wait for 1 minute, then you go reveal for another request, and if you do register, by this time you are actually revealing with plain text. But if someone fetch it, rather than just like front run, they have to go through the whole step. So you're gonna have like a fast transaction, fast commit transaction time, and 1 minute's wait time. So there's about 1-2 minutes head time. So like if this second step ends in less than 1 minute, no one be able to front run. But again, not people aware of this kind of things. So like sometimes people just try to set gas price very low to get the name with very low gas price, then is not aware that like if it takes more than 1 minute, actually other people can see what you're bidding on, and you can kind of you get snatched. So just one thing you have to be aware of it. And another thing is, yeah, once you set it, you can basically set something called reverse record, that this is a name. So what you just did now is like you bought browser 3000. So like if you look up browser 3000, it returns the address. But you can do the reverse of like given I'm logged in with this JX5A3, I want all the dApps to show my name, that which is 3000, which you can see in the OpenSea and the stuff like this one. So if you want these to be shown on the OpenSea or any other dApps, you basically have to pick which one. Like I have many of them. Like this is the one I want to show, and then you have to do the save. So that's a second step, and you need to know aware of this, because when you code, I'm also showing the code snippets of how you do that. But once you set it, and if you go there, you can see basically a bunch of kind of control panel. And in So the person who registers is so-called registrant. So you are the owner of this name. So if you want to, and also this browser 3000 is now NFT if it's under .eth. So if you want to transfer it, as long as you are the registrant, you can transfer. But quite often you might be the owner, but you may want to automate the for example, updating all these addresses. Good use cases, I think, Fleek. One of the use cases probably you guys all may want to do is like setting the IPFS content hash into this space called content. And once you do that, for example, I have a thing called, let's flip it to, let's see. Share name, and if we go to ENS is okay. Yeah, so if this is our name, ENS is, and here we put the content hash. And if you have this content hash set, usually via like IPF vignette, or just do it manually, this peril of doing a live demo, but like some issue. But usually this one, yeah, it's a bit error. But like this IPFS hash is kind of solved through this ens.is.link, which is the DNS, something called isDNS, which our team extended so that this one automatically kind of resolve content hash sets to this ENS name. And but like if you do that every time if you change the content, you need to update unless it's IPNS, and you could automate that using CI called Fleek, and Fleek actually do the this content update for you. But when you do it, you actually give the control rights, admin rights to Fleek by setting this so-called controller to their address, so that you can see that this address and this address is different. So only if you're the controller, you can set these addresses. So in this case, yeah, whereas you can still, as long as you own this registrant, you can overrule. So like, yeah, you can kind of set the smart contract to automate while you obtain the ownership, keep the ownership. So that's one way of getting the name. Another way is, what did I get? Let me just go back and forth. Let's go back to query. And my account, brother 3000. Another way you can do is, so like, you have to pay like $5 if it's ETH for every name. So you don't, if you want to have if you have lots of addresses, if you want to manage, it could be expensive. So other way is you can add something called subdomain. So like if you can say, hey, okay, I have one account, like, so let's say like for if browser 3000 owns this, and if you want to give each user their own username, you could create a subdomain just like this. I think 5 ways. And then once it's set, just like the ETH name, you can set like with a record. One thing you have to be aware is that, yeah, so that's second way. Yes. And you could even sell, this is actually, one thing is like .eth is NFT, but this one is not NFT. It's smart contract, so you can turn it into NFT, but we didn't add that capability in the version we have, but we are also working on the new version, which allow any names, including subdomain, to be NFT. But for now, yeah, let me check, it's done. to refresh. Yeah. So now you got a new name. But this is not NFT, but new version will be NFTified. And there's one more way you can do is that, for example, if you are the brand and if you discover the ENS and if you want to register, but like it could be like, for example, if you're Amazon or Nike, it might be already taken by squatters. In that case, alternative is to use a DNS name as ENS address. So one example is, for example, like Argent is a wallet. Well, actually, let me just try to do that. So this case, yeah, this Super Cyan looks slightly different than .eth page. That like it says that you appear to be the. Okay, so this one shows, for some reason, it shows the DNS owner name here. And how it works is, let me just go back to this slide. If you own this XYZ domain name, in my case, I do actually have a matoken.xyz. So, and I set it to Google Cloud Platform panel. If you enable something called DNSSEC, which is one of the kind of security feature DNS has by using kind of private key, public key signature to kind of go through the chain of the relationship of each domain. That if I have like matoken.x, there's a way to kind of for the parent domains to kind of sign that this is owned by this person, and you can retrieve the chain relationship, and by looking at this chain relationship, you can say, oh yeah, this is not like no one spoofed in the middle. So it's called DNSSEC. I think DNS security extension or something. Interesting thing is, by utilizing that information, we can actually send a proof. Anyone can send a proof that this person's, so like, and if you set the underscore ENS, so if you create underscore ENS subdomain, and if you retrieve this proof chain of proof information, we can post it to a smart contract on Ethereum to say this information of this text record is correct. And so if you do the dig, you can actually see that this the record text record is set. But there's a smart contract to be able to prove that. So by using that, anyone can actually submit the proof from here. So like what it's doing, if you go into the console page, it's just showing like this is kind of retrieving lots of like proof information, and it has like DNS key, that kind of stuff. And we can post it, and so if I do register, you can have the ownership ENS name tied into the DNS name. This transaction may take a bit of time. And because you own this DNS name, we don't require the fee. Like hold a fee on .eth so that we prevent squatters just try to claim every single name available. But in case of this DNS, that can't happen because you own the DNS name. So in that case, we have no reason to basically ask for the fee. So but you still have to pay for the gas fee, and unfortunately, this sending proof is relatively expensive. So it costs more gas than just registering .eth name. But this is kind of one-off. So like you don't have to like. In case of ETH, you have to pay $5 every year. You can renew multiple years, but you have to specify how long. Whereas this one, like you can do forever. But if you forget to renew your DNS name, the DNS information changes. So like if it's expired, anyone else can also kind of invalidate it as well. So you just have to be careful on that. So that's kind of basic of how you get the DNS name. And so second part is adding an ENS support. And so I do have a blog post about different ways to turn your app aware of ENS. So one way is this resolving ENS name, which I already showed using the like Etherscan, MetaMask, whatsoever. Then second one is setting reverse resolution. So by doing that, you see the example of OpenSea, and OpenSea shows like the address is actually reverse record. In case of this is Uniswap, a famous automated market making exchange in Ethereum. It shows you like who you logged in. So this is kind of example I mentioned as that you on the Ethereum ecosystem, people already using Ethereum address as a username, and but rather than using hexadecimal Ethereum address, it display ENS name to use it as username. And if you do have a kind of backend server, you could actually use you can send a message using Ethereum address. The Ethereum address actually get derived from public key, which get derived from private key. So by using your Ethereum address, you can sign signature says, "Hey, I am the one who owns this address." Then if you save that as a kind of cookie or something, so you can use that as your login and password without you managing password by yourself. Or if you use OAuth, this big provider, you have to rely on the password management to them. But in this case, everybody manage their own Ethereum address and their password. So like you won't be liable. So this is the way we kind of push to other people that even if you may not use cryptocurrency, you may still want to integrate login with Ethereum address as part of your login flow. And I'll kind of show you quickly. And this is other use case that if we let me just have a water. Wondering if there's any questions so far, actually. Okay, question from Why Spirit Bro 1. Can we recreate this in local for development? So is that question recreate ENS or recreate blockchain? If you are new to like blockchain development, there's two framework you usually use. One is called Truffle Suite, and the Truffle Suite is one of the oldest kind of framework when you're building a blockchain-based product, and you can kind of have a kind of it's JavaScript framework, and you can kind of create. Maybe you can go through this command, and you can kind of create a smart contract development environment. One of the stuff is they have something called Ganache, which is a in-memory kind of local Ethereum node, fake node, where you can deploy the smart contract without connecting to public net and paying gas or even not to testnet. So in our test environment, we actually deploy the whole ENS smart contract. So I can talk you through in the last when we go through our contract and repos, but we do have one. And also another one is called hard. So let me just, I'll update the link page. I'll update this as we talk so that you can also have other links. Wait. Another one is called Hard Hat. This one is more modern, newer kind of framework. And they also have an in-memory database where you can deploy. And there's another one called, so there's Truffle, there's another called Waffle, Ethereum. Waffle kind of got inspired from Truffle. And in their network, yeah, they are actually have a support for ENS, like set up ENS. This actually creates the local, like in our ENS teams, our local deployment is very complex because we kind of mimic the whole history of what happened in Ethereum, our ENS since we deployed 4 years ago, and we upgrade like twice or 3 times actually. So it's very complicated, but like in this case, they do have a set up ENS one. So you could use this one. So I'm gonna use this as well. Yeah, so hopefully that answer the question. Okay, and so setting up project, another thing so these are the framework. And I assume many of you are familiar with using React. So what I wanted to show you is there's another one called Create Is App, which kind of bundles Yang Create Is App, My Is App, and it's kind of, Create React App is a boilerplate for the React project, because like one of the nightmare thing about JavaScript is like there's so many frameworks, and just setting up it takes a lot of time. So there's something called Create React App, and I think it's kind of fork or some sort of plugin that allows you to install all the core component of like smart contract deployment framework using hot and some like boilerplate app page. So I was going to use this as a kind of demo to build upon. So like if you want to do it, basically you do Yang Create Is App and your app name, and you just like install it. And after that, if you go to Yang Create React, it starts up. And what it does is it shows this kind of page. And I think I was halfway through editing. And this one is, let me just stash fast. This is my demo. Yeah, stash. So when you just installed, it looks like this. Yeah, and it has a page called, there's things called Wallet Connect, which kind of abstract the ways to connect to various wallets. But if you do, let me disconnect first. And if you do connect, it shows you whether you want to connect through MetaMask or Wallet Connect. Wallet Connect is another one which allows you to connect to your decentralized website through your mobile wallet, such as like a Trust Wallet, Coinbase, they don't know, like Rainbow Wallet, that kind of stuff, or like MetaMask. So like if you connect, it gets connected. And so if you go to, I think what you do is, for example, if I have, yeah. So in their demo, what they say is like, there's a page. Yeah, read on-chain data is how you connect. And they use something called Ethers.io. So this is another popular project. When you use a front-end app, you use something, it's either called Web3.js or Ethers.js. And I think Ethers.io are getting more momentum. And actually the developer of Ethers is actually part of, like he partly works on ENS team as well. So he has a lot more integration with ENS. So most of the dev document, if he goes to docs.cs domains, libraries, it shows you a list of the library it supports. And it shows you the basic way of doing it using this Web3.js, which is a fast kind of JavaScript library into with Ethereum. The ESAS.js is kind of now upcoming one. And the ENS.js is the one we create. And this one has the most support of most of the utility you can do. Like ESAS.io is mostly for like lookup only. So if you want to set address through your app, you either use Web3.js or ENS.js, or you just connect to the smart contract directly. But in their case, they already have ENS support built in. But before going that, so like if you just want to play with this page, yeah, so I copy and paste. And if I want to see the ERC balance, oh no, maybe I don't have balance on this one. Yeah, let me just, if I do hidden. Yeah, now it says read on chain balance. And now it says here, it says that address, which was hard coded, has this token balance or fake token. So it already knows how to connect to Ethereum address, and it knows how to disconnect and connect to wallet. So this is very good starting point. And that's the basic usage. But what I'm going to do is, I have something. Pop. Yeah. And if I do stop. And then I'll show you the diff. Diff is basically what I did is I did ESAS, the whole project. Like ESAS is very modular, so you can have like specific, you can cherry pick specific project you want. But in my case, I was actually playing with the library just like 5-10 minutes before this session, and just realized that it doesn't come with what I want by the just default provider. So I just installed the entire stuff. But so now instead of read balance, it says read address. So if you click this, it shows that basically I'm connected as matoken.is, which is true. Like I'm a matoken.is, okay? So how do I do that? So let's check. And what did it? Yeah, so I only added this one. So I added a new button called read address. And the read address, what it does is like, so it's, maybe I can compare with this one. So this read on chain data, sorry, is you first get the provider, default provider, and you pass the provider into contract of the ERC20 contract. So like you can, by doing this, you can connect to any smart contract. And also this could be the way if you want to connect to our various kind of smart contract, is that you pass the address and ABI, which is oh, nice. Yeah, so it shows you what kind of functions exist. So there's a constant, and yeah, like balance, that kind of stuff. So it's a JSON file consists of like function information. And if you pass it, then you can, and this is a kind of called function call where you ask the balance of the coin to Ethereum address. And so in case of ENS support, what you do is like I added to this Web3 provider instead of using default provider because it didn't have functions I wanted to use. Then I asked provider a list of accounts, so who this provider is connected to. And so like if I go to, so I did a console log, right? So if I go to accounts, so you can see this account is added, JX5A. Then after that, accounts ID says get resolver. I don't know this. Yeah, and then I pass the ENS name, and then I pass something like this. But I'll explain. I think resolver is something else. Yeah, but what's important is, yeah, you look up to this address and I pass the 0x5A and then it gets a name. So this is a way to set up, look up the reverse record. And resolver, I'll just, but like, I think this is a basic lookup address. So like, yeah, lookup address is how, given passing same address, how you get a name. I think resolve name is actually how you do. So like, and I think address. Let me do that. So I was in the middle of making this thing. Read address. Yeah. See, like you can see the address is, I first look it up with this matoken.is and I got address. But now I pass lookup address is I pass address and I get the name. So this is kind of simplest ways to interact with ENS. And probably in last 5 minutes, or am I okay with time? Yeah, I think I have another 5-10 minutes, hopefully. So I think I said, I'll mention that. So if you do any of these, you are entitled to apply for the bounty. And I think we will just pick like, because integrating with ENS is relatively easy, we'll rather just, first we check, like, did you actually integrate with ENS? Just paying $5 to register or just pressing the button isn't qualification. Did you use any of these things to show a same address? That's one of the qualification reasons. You could, if you create your project and if you put this on hosted on IPFS, and if you provide ENS name, that may or may not qualify because it doesn't technically require any dev effort, but that's slightly more than just you buying your ENS name. So we may qualify, but it's up to you. But if you really want to get to the meat of it, you could look into the our documentation page. That it has a whole information with smart contract, but it talks about architecture. That I mentioned that get resolver. What is get resolver is that basically when you first speak to lookup name, it goes to ENS registry smart contract, which is another smart contract. And if you do say, hey, give me resolver of foo, it returns so-called resolver contract address rather than your ECM address. Then you ask the individual resolver how to resolve this foo.is, and then you return the address. So it's kind of 2 steps. The reason we did is that smart contract is known for kind of the code is low, and once you deploy, you can't really change it unless you point to the new address. Then every time we upgrade, we're asking people to kind of point to the new contract. Is a lots of maintenance cost. So one of the patterns is you just kind of separate out the kind of get proxy intra contract, which is registry, and the actual logic, so that this logic you can keep revolving. So in the very beginning, when we first deployed the ENS, it didn't have support of IPFS as we have right now, but we just added, and then we just said, hey, people just points to the new resolver. But if people using the old one, people can still use old way. And so that's kind of, and we also added new things like a different coin type. Like now you can save like Bitcoin and Doge Litecoin. You can do it because you create a new resolver. And Yeah, so that's a basic. Only thing, so if you are actually keen on actually like getting more into the smart contract itself, I can tell you where you go is GitHub. So the app we just showed you for the this site is here, which has the basically like has the most extensive use of everything. So you can look into it. But actually, what it's connecting to the smart contract is down at the UI layer. And so UI has a kind of extraction of like all things. So if you are not quite sure how it's using, you could look into this contract. Then the actual contract itself, a majority of them are in the ENS contracts. So you can look into this repo and it has pretty much everything. I think that's it. One more thing is that, so another thing it's hard about smart contract development is that it's relatively easy to see what's this ENS name or what's giving the address. You can find the address associated to the name or name associated to address. That you just call smart contract. One thing slightly difficult is show me all the names I own. For example, like this page, my account page doesn't exist on the smart contract itself. That there's no function to say show me everything you registered. But we usually smart contract emits something called event, which everything like new names get registered, emits events, and usually there's a function to subscribe to the events. But like if you go through like over 2 years worth of like my history, it takes forever. So there's a other project called the Graph project, which kind of made lots of these events you allow, and it turned into graph. Like graph is a GraphQL, like a bit like REST API, but like more extensible. You can customize your own schema, that kind of stuff. And so if you go to the Graph ENS, this is almost like you can query into your database. So like if you say, okay, so what is the name? Wait, let me just make it slide bigger. Name is this. So it shows like who owns this information. But also you can say accounts, domains, name, where, owner, ID. Let me if I do this, it shows that it says account my token is owned by the X5A, right? So if I want to say what the list of all names I own, then I think if I do where ID, something like this. Yeah, see, so it now shows all the names that it owns, and so this is it's all indexed, and you can query through a GraphQL. And if you go to GitHub, subgraph, it has something. And then also, if you look into, this is a schema. It's defined, right? Like domain, account, and registration. You can, I think, look into it with this information, and you can write your own kind of indexer to index the events into the schema. It's more suited for you to query. So this subgraph we often use. So if you want to have some kind of data analytics and stuff, you could look into our graph schema. I think this is pretty much it. Any other questions? Can we? Yeah. So this one answered. So let me just copy and paste other stuff. And yeah, I think this is it. So I'll tidy up and I'll update after this talk. But if you have any other questions, yeah, you can just tweet me to my Twitter, or you can read more in the documentation, or you can come to our Discord channel and you can ask questions. Okay, that's it.
Thank you so much, Makoto. There is a last question if you just want to answer this one here or in sync.
Okay, where does it fetch the graph data from? Where is it stored? That's an interesting one. So let me just. If I go here, let me just check one of the example of the registry. Yeah, so there's things called event. So if there's a new owner came, is created, it emits the event. And if you go to ENS subgraph, when this new owner event happens, you create something called handler. And if you go to handler, it has a logic. Handle new owner creates this account and it does a save. So when this save happens, currently there's a company called The Graph who basically invented this or indexing scheme tailored for smart contract. They store in their Postgres database, I think, but then they are currently in the middle of decentralizing it. So now they have something called indexer and curator. I'm actually part of a curator that like anyone can basically. So this whole infrastructure, you can actually go to the I think Graph's website and you can download the index as a I think it's a Go or Rust. Like if you go to the Graph. Graph protocol. Yeah. So if you download the indexer, you can download the indexing software, which actually have an IPFS and a Postgres database and it stores. So you can actually index on your own because everything is open source. So you can just index, or you use a hosted service, but because they're trying to decentralize, probably at some point they're going to decommission. Or yeah, you ask these decentralized bunch of indexers, I think there's thousands of them, ask them to index, and they have a token called GRT. So like you pay per query. So if you don't want to maintain, you probably have to pay for these decentralized bunch of indexers to index for you, and you pay it. Or if you don't want to pay, you download their software and you host on your own. I think good. Okay, I think I answered the last one as well.
Amazing. Thank you so much, Makoto, and thank you for everyone for joining us. I'm posting our landing page, so if you'd like to join any other learning sessions we're going to have for the next few weeks, please do. And yeah, happy hacking, everyone. And thank you, Makoto, again.
Yeah, thank you so much for having us. And yeah, good luck, guys.